So, question to you all. What did we learn in the last class? Yeah, Dikshita and Tanu.
Distance between 2 points.
Okay. Dikshita, same.
Coordinate geometry.
Coordinate geometry is what we started with. Yep.
We learned coordinate geometry.
Okay. Okay. Arihan, same thing? I hope everybody is learning the same thing in the class, right? Okay.
How to find the length of a line in
Alright.
whatever.
So let's look at what did we learn in the last class and what we want to learn now. And again, you guys will be surprised to know that whatever you have learned now, these are the concepts that will be useful for you guys from 6th to 8th grade, as well as even part of it is taught in 10th grade also. So you guys, if you understand the concept, you'll be well ahead of your grade. Now, am I trying to scare you guys? No. I'm saying that whatever you learn, no, whichever topic you learn, if you learn it in a conceptual way, that will last with you much longer. So let's focus on that and see what we have learned versus what we need to learn more. Okay. So we learned. Hi Sundara. So I'm not missing anybody. We are missing few kids. Everyone is not here. Advik and Arav are not going to join. Okay, that's okay. Whoever is missing the class, they will have to watch it offline. So we learned that this is my coordinate plane. If I have to find out the distance between the 2 points, then we use the distance formula. Yeah. And in very simple form, if you visualize this, if you have to find out the length or the distance between the 2 points, look at my drawing skills. It's pathetic. If you have to find out the distance between these 2 points, okay, assume this is straight line, okay, it doesn't look like straight line by any standard, but assume that, okay. If you have to find the distance between these 2 points, what we have to do is, how do you find it out? You need to find out this length and this length, and if this is 90 degrees. If I convert this line, or if I visualize this line like a right triangle, okay, meaning if I find out this length and do a square of this length plus this length equal to a square of this length, which is coming from Pythagoras theorem, right? We should be good. And that's exactly what we learned in the previous class. Meaning, if you have to find out this length, this point, let's say the coordinates are x1 and y1, and here point B, the coordinates are x2, y2. The length AB will be equal to square root of x2 minus x1 square plus y2 minus y1 square. Now, this might look very complicated, it is not. If you look at this one, this is a right angle. If you take this point, what is the distance on the x-axis? This is x1. What is the distance on the y-axis for this point? Is y1. That's why the coordinates are x1, y1. Meaning this length is y1, this length is x1. Similarly, for this point, if you see, what is the distance on the x-axis? This is x2. And what is the distance on the y-axis? Here to here, this is y2. So that's why this coordinate is x2, y2, right? This is on the x-axis is x2 and on the y-axis is y2. Yeah, on the y coordinate. Are you guys with me or I'm boring you guys? Bhuvan, Pranav, Myra, Hiranya, everybody? Hiranya, you are very quiet, beta. Are you with me? Okay. So see, this is very normal. Some kids talk more, some kids don't. But I have to make sure that everybody in the class is with me. Like Vasantha doesn't talk much, okay? She doesn't like talking to me at all. But that's okay. As long as I'm able to explain things to her, I still feel my job is done. Okay? So that's why I keep on poking you guys just to make sure that I'm not teaching myself or I'm not teaching only one or two kids in the class. Okay? Yes, Vivwan.
I just joined the class, so I don't really know. I don't really know what you're talking about.
So did you join the last class? I think you missed the last class.
Yeah, I missed it.
Okay. So we are talking about a topic called coordinate geometry, meaning you have a coordinate plane and then you impose geometry on the top of it.
Okay.
So we have learned only one thing, that is called the distance formula. Meaning, if in a coordinate plane you have 2 points A and B, yeah? Okay? If you have 2 points in the coordinate plane A and B, okay, Ritika joined now. Hello.
Is Satvik or Siva here?
So not so Shiva, Kesava and Yug, they both came and they both went with Yug's father actually.
Oh, they did? Okay.
Yeah, okay. Sorry about that. Alright, so here we are talking about a coordinate plane where you have 2 points A and B. Okay, so Ritika is here. So Ritika, a message for you. I thought that you will be joining the class at 3 o'clock.
I can't join that class because I have like another class. I have like gymnastics like right before this, so I can't.
Okay, that's okay. So we'll talk on that one. So we can continue this class for now. Don't worry about it. I and Mommy were having a discussion parallelly, so we'll talk about it. We'll sort it out. Okay. So here we talked about the 2 points A and B in a coordinate plane. A had the coordinates x1, y1, and B had the coordinate x2, y2. Up to this much is clear to everybody, right? Even Vivwan. And the kids who were there in the previous class, Ritika, Tanu, Vivan, Nihan, everybody clear, right? Okay. So I have these 2 points. I am trying to find out the distance between these 2 points. Okay. Now, what we are doing here is, this is my point x1, y1. The coordinates are x1, y1. This is my point where the coordinates are x2, y2. What does the coordinates mean? That means the length along the x-axis or the length along the y-axis. That is what the coordinates are, correct? Yeah?
Yeah.
So that means if this has x coordinate is x1, y coordinate is y1, what it means is along the x-axis the distance is x1 and along the y-axis the distance is y1. Everybody with me? Similarly, this has x2, y2 as coordinates, meaning the distance along the x-axis is x2 and the distance along the y-axis is y2. Up to this much is clear?
Yes, sir.
Now, from this point, let's draw a perpendicular line here, and from here draw a perpendicular line here, so that we can visualize this better. Now this looks like a right angle triangle. Let's say this is AB. I will give this point a name C. ABC looks like a right angle triangle, correct? Because that's what we have done. We have drawn perpendicular, right? So, if I have to find out this length AB, any right angle triangle, Mr. Pythagoras or Pythagoras uncle, whatever you want to call him, he has given one formula for a right angle triangle. That if you have a right angle triangle, this is A, this is B, meaning A and B are making that 90 degree, and this is C, then A square plus B square equal to C square or hypotenuse square, whatever you call it. A and B are two sides which are making the 90 degree, and C is the side opposite to the 90 degree angle. So A square plus B square will be equal to C square. That's what the Pythagoras theorem says. So here, why I am talking about this stranger is because this is my right angle triangle. If I have to find out this length, which looks like the hypotenuse of this right angle triangle, I just need to know this length, and I can apply the Pythagoras theorem. So that would mean I can say AB square, which is the hypotenuse square, equal to this square plus this square. What is this square? AC square plus BC square. Now AC square, AC here to here. Can somebody tell me how much this will be? AC? AC square. AC is how much? This is x2, this is x1. So x2 minus x1, this is what this length would be, correct? This is x2, here to here is x2, here to here is x1. If I am trying to find out this length, the middle one, this will be x2 minus x1. That's what you will get here, right? Correct? So x2 minus x1. So AC is x2 minus x1. So AC square will become x2 minus x1 square. No disagreement with the teacher, right? Anybody disagreeing with me right now? And it's okay to disagree if you're not clear, okay?
I am not disagreeing with you.
Okay, better for you. No, I'm not scaring, okay? I'm just kidding. Okay, Myra, are you with me?
Yes, sir.
Bhuvan, is it okay so far? Ritika?
Yes.
Yeah.
Okay. Now, AC square we got as x2 minus x1 square, and I will rush through this and say BC square is also y2 minus y1 square. Why? Because BC is this length, which will be equal to this length minus this base. This length minus this is what will get you this length, right? And this length here to here is y2, because this is the y coordinate, and here to here is y1. So y2 minus y1 is what will be this length, BC. That's what I've written here. Yeah? So AB square gives you x2 minus x1 square plus y2 minus y1 square, where x1, y1 is the coordinate of the first point, x2, y2 is the coordinate of the second point. Yeah? So AB will be equal to square root of whatever you have here, plus y2 minus y1 square. Yeah? So this is what is your distance formula when it comes to coordinate geometry. When you have 2 points x1, y1, x2, y2, if you have to find out the length between the two or the distance between the 2 points, this will be subtract the x coordinate for the second point and subtract the x coordinate of the first point from the second point, square of that, plus subtract the y coordinate of the second point minus first point, square of that, and do a square root of the whole thing. You get this formula that is called distance formula in the coordinate geometry. Is this okay so far? Yeah? No problem, no confusion, and that is what gets me excited to get you guys confused. That gives me a reason, because I don't want to stop and say, hey, everybody is happy. No, that doesn't make me happy. I want to make your life more difficult. No, not making difficult. I'm just trying to make you guys learn something more difficult in an easier way. That should make you feel easy or feel comfortable. Now if I say, you guys know that, okay, if I have 2 points A with coordinates x1, y1 and B as x2, y2, if you have to find out the length, you will say easy peasy, I don't care. x2 minus x1 square plus y2 minus y1 square, find out the value, do a square root, done. But if I am saying that find out a point, so if I join these two and make this line AB, I am saying find a point, let's say C on this line, so that this point C divides this into this ratio, M1 is to M2. Stressful. Yeah? Again, I'm repeating it. So, don't worry about the mathematical part of it. We might not have to solve it right now. I'm saying, I have 2 points A and B. A has the x and y coordinate as x1, y1. B has the x and y coordinate as x2, y2. So when you join these two lines, you can find out the length. You know it by now. Applying the distance formula. Not a problem. I'm saying, find out a point C or the coordinates of the point C. Any point in the coordinate plane can be distinguished or identified only after knowing the x and y coordinate, right? So I'm saying, find out the point C on this line, which is joining x1, y1 and x2, y2, such that C divides this line into this ratio, meaning this part by this part. Length of this part divided by this part is m1 is to m2. Or I am saying, let's say AC by CB equal to m1 by m2. Now m1 could be 5, m2 could be 7, m1 could be 10, m2 could be 15, doesn't matter. I'm saying, I'm just giving you a variable situation. How will you find out the x and y value relating to these 2 points and the ratio? This is the second part. So basically when you talk about coordinate geometry, there are 2 things primarily that we need to learn. One is the distance formula that we have already learned, and this is called section formula. Who all are scratching their head? Please don't do that. Otherwise you will lose hair and become like me. Don't do that. Now asking you guys, have you understood what we are trying to do? In a simple way, I have 2 points. When I join them, it makes a line or line segment. We are trying to find out a point lying on this line such that it divides a line into 2 parts in this ratio. That is what we are trying to find. Are you okay with that? I have 2 points. When I join them, it makes a line segment. I know the coordinates of this point and this point. I have to find a point C which is lying on the line somewhere such that it divides a line into this by this ratio. Yes, Dikshita.
What's the M in the bottom? Like you said, M1 divided by M2.
Yeah, so M1 by M2, that is the ratio. Meaning when you pick a point here, this divides a line into 2 parts. So this is the ratio in which it divides, right? Let's say you have let's say you break this eraser into 2 parts. That one part is half of the second part. So 1:2 kind of a ratio. If I say break this into 2 equal parts, so this part by this part will be 1. So this side's length by this side will be 1. If I say break into 1:3, so this part divided by this part will be 1:3. So this part is bigger, this part is smaller. So that is the ratio we are talking about.
Okay, sir.
So did everybody understand what we are trying to achieve here? Ritika, Arihan, Gitesh, Myra, Bivwan, Vihan, Pranav, everybody. Everybody clear what we are trying to achieve? At least let's find out what is the goal. How we will come to that. Okay? I need to drink some water. Now, before I get you guys stressed out and make you guys lose some hair, let's go back to what we have learned in the past. That is around the concept for similarity of triangles. If I have 2 triangles, this and this, when I will call them similar? Do you guys recall? When are 2 triangles assumed to be similar? Who recalls? Go ahead. Go ahead, it's okay. See, I have never learned things in one go, okay? I keep on forgetting, I keep on making mistakes. That's why we end up revising. That's okay. So it's fine. Don't be shy of making mistakes. Yeah, Gitesh.
We learned the 4 theorems, side.
No, that is congruence.
Okay.
I'm saying similarity, okay? Yes, Arihan. When are 2 triangles similar?
I would be thinking it would be angle.
Yes. That is the right statement. Yeah, Ritika. Same thing?
Yeah, I was gonna say when the corresponding angles and both triangles are equal.
Alright.
This low.
So basically, two triangles will be similar. Mind it, similar. Okay. I'm not trying to be Dhoni and say mind it one more time. So I'm saying when two triangles are similar, there is a difference between similarity and congruence. When you say something is congruent, that is exact replica. These two hands are congruent, thankfully, by God's grace. Okay? These are congruent, they are exactly the same. Now, this triangle and this triangle will not be able to say they are congruent. They might be similar. And similarity has more to do with the zoom in, zoom out that you do on your phone or camera or laptop. You have a small picture, you zoom in, this looks bigger. This is a bigger picture. And why it becomes big or small, that is where similarity comes into picture. This angle and this angle are same. This angle and this angle, if I call this as 1, this is 1, this is 2, this is 2, this is 3 and this is 3. Angles are same. The inclination between the angles are the same. Sides are not same. Dikshita, you were trying to say something and then you put your hands down. So I'm just making sure that you are with me. Yeah?
I was about to say congruence.
No. So congruence. So when you say, so again I'm repeating myself, but congruence and similarity are two different things. When you say congruent, that is an exact copy, a Xerox, photocopy. Right? I and Gitesh cannot be congruent. Okay? I'm way too old, Gitesh is way too small, but we can still be similar. Meaning, when you looked at the zoomed in version of Gitesh and if that looks like me, then probably we are similar. Okay? But I and Dikshita cannot be similar. Okay? Because Dikshita has long hair and look at my situation in which way. So, we both cannot be similar. Right? And obviously there is a gender thing also coming into the picture. But on a serious note, when you talk about similarity, you are saying you are only comparing the angles. When the angles remain the same, size can be big or small, like how you see things by zooming in, zooming out in a phone. That is similarity. Okay, your angles don't change. Your triangle will not become like this, no matter how many times you zoom in or zoom out. Okay, they look similar. It will become small, or big, but it will not become anything else. Yeah. So that is similarity. Now why I am emphasizing on similarity? Because similarity is what will bail us out with this problem. Okay. Now, if you guys recall, when you have two triangles similar, what does it mean? The sides will be in the same ratio, same proportion. Do you guys believe? Do you guys remember, recall? If the two triangles are similar, let's say this triangle ABC and triangle DEF. If these two are similar, that means, let's say this angle 1, this angle is also 1. If this angle is 2, this angle is also 2. This angle is 3, this angle is also 3. Now they are similar. The angles are matching, the sides are not. So here what it would mean is, when there are two triangles similar, their sides will be in the same proportion. Meaning, the side opposite to this one, this is side opposite to this angle 1 is BC. So BC divided by side opposite to this one, EF, will be equal to, take the second angle and the side opposite to that. This is AC. AC divided by side angle 2, side opposite to that is DF. Will be equal to, take the third angle 3B, this is AB divided by DE. What you see here is, when the two triangles are similar, their sides are in the same proportion. This is what we have learned when we talked about the similarity of triangles. If you guys don't remember that, then you are becoming as forgetful as I am. Yeah? Who remembers and who doesn't remember? It's okay. In this class, nobody has to be shy. Okay? It's okay. We don't remember everything. Making mistake is okay. So who honestly thinks that you remember and who thinks that you forgot?
Sir, I think I forgot.
You forgot? I love that honesty. Whoever is being honest,
I think I forgot.
you also forgot? Okay.
Okay.
Yeah. No, and forgetting is no crime. Forgetting is certainly no crime, but being honest is more important. So whoever acknowledged, said, okay, I forgot, you have earned some extra respect from me. Okay? Alright? And that's okay. Being honest is a very, very big thing, trust me. Let's go where?
Oh,
Pranav? Guys,
Yeah.
don't do any chatting in parallel, okay? Alright. So now we have two triangles which are similar. So Ritika, had you come across this concept before, or this is something that is new?
Well, I've learned like this before, like the proportions and like similar triangles.
Right. So, I mean, I'm just trying to make sure that everybody is with me. When it comes to understanding, when there are two triangles which are similar, the only takeaway for us is that the sides will be in the same proportion. Okay? Let's keep that concept with us, and then we'll go back to this, the section formula for coordinate geometry. Now, a quick question to Ritika. I'm not trying to put you on the spot, but okay, I'm just asking you. Have you heard about this formula before?
I like heard of it, but like I didn't really learn it.
Okay. No, so at least I want to make sure that everybody is learning with me. I should not be wasting time for everybody. So that's what I was just saying. So this is my coordinate plane. Okay. So now we are going with understanding that when we have similar triangles, their sides are in the same proportion. That is the understanding we are going with. Now let's come to this point. We have a point A with x and y coordinate as x1, y1. Point B with the x and y coordinate as x2, y2. And we are trying to find out the point C, which might have coordinates as x and y, and we don't know how much they are. But a point C on this line, such that the point C divides this line into the ratio m1 is to m2. This part is clear, right? What we are trying to achieve should be clear first. Yeah? Arihan, Myra, Bhuvan, everybody understands what we are trying to do? Okay.
Can you repeat?
Okay, so I'm saying what we are trying to do here is, okay, guys, stop. Hiranya, you are very quiet, beta. Are you with me so far? Hiranya, okay. So I will keep on, I keep on randomly calling out names like people like Vasundhara. Vasundhara is very quiet, yeah. So I keep on calling out names just to make sure that you guys are with me, okay? I should not be wasting your time, right? So when we are in the class, if there is something that I am able to explain or not able to explain, I certainly want to interact with you guys to make sure that you are with me. Okay, now coming back to this one. So hear me out for next 5 minutes, okay? These are golden words. Every word is worth $1 million. Let's see how many millions you are collecting right now. Okay? So the situation is, we have 2 points A and B in a coordinate plane. Point A has coordinates x1 and y1. Any point will have x and y coordinates, right? We have x and y coordinates as x1, y1. Another point B, which has coordinates x2, y2. Right? Every point has to have x and y coordinate value, right? That's how you locate anybody or any point in the coordinate plane. Now, you join A and B. By now, you guys have learned the distance formula. So if somebody says, okay, find out the distance between A and B or the length of line segment AB, you'll be able to figure it out. Not a problem. Here, what we are trying to say is, when I join point A and B, there is a line segment that we created AB. Find a point C on this line segment AB such that this point C divides this line into ratio m1 is to m2. Meaning here to here, by here to here is m1 by m2. That's what I have written here. That's what we are trying to find out. Meaning find out a point C such that it divides this line into this ratio. Now when you are saying find a point C, that point will be pointless if you don't know the x and y coordinate, right? So basically when you're trying to find out the point C, you are essentially trying to find out the coordinates of point C relating to this and whatever you know. Is that part okay? Day one, question for you, beta. Did you understand what we are trying to achieve?
Yes.
Okay. Now, Pranav, you were trying to say something. It was Vivan. Okay, sorry.
I wasn't saying anything.
Okay. I heard somebody unmuting for a little bit. So Thanu, you are with me, right? You seem to be in a it's called rainforest. Okay.
Yeah, I understand.
Yeah, okay. Okay. Alright. So now let's make this board look dirty first. Okay. So now A has coordinates x1, y1. So what we'll do is we'll draw a perpendicular. So here to here this distance is how much? x1. And here to here the distance is y1. No question with this, whatever I've done, right? What I have done is from A, I have dropped perpendicular on x and y axis. I am saying this length is x1 because this is my x coordinate and this distance is y1 which is my y coordinate. So far nothing to get worried, right?
Yeah.
Now from this point also let's draw a perpendicular here and draw a perpendicular here. What is this distance? This distance is y2 because this is my y coordinate, right? For this point. And here to here is nothing but x2 because that is my x coordinate. Yeah? Nothing confusing so far? Ritika?
No.
No. Okay. Now from here also we'll do the same thing. Okay? Now assume this is x and y. So here to here is my y coordinate. So this length will be y. Here to here is my x coordinate. This length will be x. So far no problem. I am doing all stupid stuff. So it should not get you guys confused. Now I will draw two more lines. From here I will drop a perpendicular here on this point. And from here I will drop another perpendicular here. So this point is C, this point is A, this point is B. These are 2 points. Let's give it a name also. Let's call this guy D and let's call this guy E. This Y is my length from here to here. Okay. So now I have 2 triangles ACE and I have another triangle BCD. Okay. I am just telling you guys that I want you guys to believe that these 2 triangles are similar. Do you think I can dare to say so? Arihan thinks that I can say these are similar. What? Why?
Because I can't really explain it, but can you just draw 2 straight lines somewhere? Just 2, like when you have an intersecting line on
Parallel line?
a diagonal line on that intersects one of the 2 lines, the 2 angles have to be the same, and that's what's happening right now.
Okay. Let's see if Nihan has a different definition. Yeah, Nihan.
I'm pretty sure last class you said it was corresponding.
Corresponding angles, yeah. So which one is corresponding? So let me give it a name, okay? So let me say this angle is 1 and I say this angle is 2 and I say this angle is 3 and I am saying this angle is 4, this one is 5 and this one is 6. Now you tell me, giving the name, related to the name, which 2 angles are corresponding angles? This is 1, 2, 3, 4, 5, 6. Yeah, Nihan, go ahead.
3 and 6.
3 and 6, you are saying they are corresponding angle. Okay. Let's see what Gitesh has to say. Tell me which one is corresponding angle.
I think 2 and 5 is the corresponding angle.
2 and 5 are corresponding angles. Okay. Yeah. So here's the thing. So yeah, Rihan, you want to add something to it?
1 and 4.
1 and 4 are corresponding angle. Okay. Makes sense. So look at this. First of all, angle 3 and 6, we don't really have to worry about because both are 90 degrees. Okay. Because you have dropped perpendicular on this opposite line. So this is 90 degree and this is 90 degree. So there is nothing to worry. Both angles are matching. So between this triangle and this triangle, these two angles are matching. And as Gitesh said, 2 and 5 are corresponding angles because these two are parallel lines. And so when you have two parallel lines, okay, and then one line draws like this angle and this angle are corresponding angle. So these two are parallel lines, this is an intersecting line. Both the angles are above the parallel lines and on this side of the intersecting line. So these two are corresponding angle. Similarly, so 2 and 5 are corresponding angles. Similarly, somebody said that somebody was who? I think Arihan said that 1 and 4 are also corresponding angles because again these two are parallel lines only, parallel to the x-axis. So these are the parallel lines and this is an intersecting line. So again these two becomes a corresponding angle. So you found all the three angles between the two triangles matching. So they are similar. Yeah, Gitesh.
In the last class, you told a little bit about this section formula, and then you stopped right here, and then this class you said you were going to continue.
That's what I'm doing right now.
Yeah.
So, and again, when I'm teaching, I cannot blindly go from one place to another. If I see there's any even smallest of doubt, when I was asking you guys what is similar triangle, I found all diverse answers. So that is why I had to make sure that everybody comes to the same page before I proceed. Okay, that's why I cannot leave any child in the class unattended and just finish the subject for the sake of finishing it. Okay, all right. Everybody with me so far? So now, based on whatever we did, agreed, disagreed, we finally found that this triangle and this triangle are similar. Is that a fair statement? Okay. Now, when the triangles become similar, that means the sides will be in the same ratio, same proportion. Now look at this angle, angle 3 and angle 6. I will give them same name. So this is also 3 now. This 2 and this 5 are same. I will just call this guy also 2 so that there is no confusion. This 1 and this 4 are same. So this I am calling it same name. So this is 1, 2, 3, 1, 2, 3. These are matching angles. Now, so the sides will be the same proportion, meaning this by this. What was the ratio? M1 is to M2 will be equal to this by this. Both are opposite to this 90 degree angle, third angle will be equal to the sides opposite to angle 1 and 1 here. So this is will be equal to, this is EC divided by BD will be equal to the third angle, this one, 2 and 2 will be equal to AE this side divided by this side, which is CD. So here, from whatever we have done, what we did was we have drawn this line and then found a point C which has, we assume that is the X and Y, and then we have dropped perpendicular so that we can measure the length of all the sides, and then we found that this triangle and this triangle are similar. That means this divided by this will be equal to this divided by this will be equal to this divided by this. That's what we have written in this formula here. So you can, okay, please stop any parallel talk and stay on mute, otherwise there will be a problem. Okay. Now M1 divided by M2 equal to EC by BD, or we can say M1 by M2 equal to AE by ED. by CD, sorry. Now EC is what? EC is this length. That will be equal to what? This whole length is x and this whole length, this whole length is y. This is the y coordinate. So y minus y1. So this one EC will be y minus y1. Y minus y1. Similarly BD will be what? BD will be this one. So this length is what? This whole length is y2 minus y. This is y. So y2 minus y. So this is y coordinate of the C point. y2 minus y. This gives you this length BD. We have just put the value here in this formula. Similarly AE. AE is this length. So M1 by M2 equal to AE by CD will be equal to this by this. So that's what similarity of triangle says. So we are just putting the value here, okay? So AE, this one, AE will be equal to this length minus this length. So this length is, this is x coordinate of point C. So x minus this length, which is x1, divided by y2, CD. CD is this one. So the CD is what? Here is x2 minus x. So here, if you look at these two formulas very carefully, from this one we found two values, two relationship for x and y, which says m1 by m2 equal to, from this one gives you y minus y1 by y2 minus y, and the second one says m1 by m2 equal to x minus x1 by y2 minus y1. What I am doing here? X minus x1 by x2 minus x. So look at this. M1 by M2 ratio has similar relationship. M1 by M2 equal to y minus y1 by y2 minus y. M1 by M2 equal to x minus x1 by x2 minus x. Meaning in terms of x and in terms of y. How do you relate this? This is what we have got. But let me stop here. Before you guys get really stressed out and start thinking what exactly we are trying to do here. Summary of this is, we have 2 points with coordinates x1, y1, x2, y2. Meaning x1, this length is x1, this length is y1. This length is y2 and this length is x2. We are trying to find out a point C which will divide this line into m1 by m2 ratio. What we did was, we dropped perpendicular so that we got this triangle and this triangle. Now we say that why we are trying to get these two triangles, because our goal is to find, see, we have to find out this ratio, this by this, and ratio comes only through similar triangles. Similar triangles only tell us, right, the ratio, sides will be in the same proportion. So that's why we are trying to prove them similar. So we looked at this triangle and this triangle, we found they are similar. If they are similar, meaning this by this will be equal to this by this will be equal to this by this. That's what similarity of triangle says. Do you guys agree or you don't? Yep. Yes, Gitesh.
I'm a little confused.
Why you have to be confused purposefully? Did I do anything different here? I am just repeating myself. I am saying that I have 2 points A and B.
Yeah.
A coordinates are x1, y1 and B coordinates are x2, y2. Okay? I am going very simple. Now, find out the point C on this line so that it divides this line into this by this ratio, m1 by m2 ratio. Whenever you talk about ratio, only one concept, only one theory in the world helps you with the ratio, that is similarity of triangle. Similarity of triangle says sides will be in the same proportion. That's why we are relating to that, okay? We are going that path. So, we said, okay, fine, m1, find a point C such that this by this, C point gives in this ratio. So what we did was, we dropped perpendicular from all the points so that we get the x and y value, length of the sides for x and y. And we found that this triangle and this triangle are similar. Up to that is clear, right?
Yeah.
When these two triangles are similar, then we found that, okay, this by this, since these two triangles are similar, meaning the sides will be the same proportion. So m1 by m2 will be equal to this side by this side, and also m1 by m2 will be equal to this side by this side also. That's what similarity of triangle says. That's what I've written here. m1 by m2 equal to EC divided by BD will be equal to AE this by CD. So m1 by m2 will be equal to this by this or this by this. That's what we have written here.
What I didn't understand is how is it going to be M1 equal to EC and M2 equal to, I can't read that.
BD. No, I did not say that M1 equal to EC and M2 equal to BD. I never said that. I said M1 by M2, the ratio of this will be equal to ratio of this. And that is exactly what similarity of triangle says. Okay? So I will never dare to say that the sides will be same. I am saying the ratio is same. It's like 1 by 2 versus 2 by 4. The ratio is same. It's 1 by 2. 1 by 2, 2 by 4, 3 by 6, 4 by 8. The ratio is same. The value you get is 0.5. I will never dare to say 1 by 2 is equal to 3 by 4 because the value is not matching. Correct? So here also is only the ratio that is same. So m1 by m2 equal to m1 by m2 equal to this by this, or m1 by m2 equal to this by this, because the ratio will be the same. The sides will be the same proportion. That's what it says. Is everybody able to follow me? Arihan, Pranav, Vihan, Tanu, Myra, Nihan, Ritika, Dikshita. Okay, so we got this. We got m1 by m2. I mean, see, AE, EC, CD, these things don't make sense to us. We know the x and y coordinates, so we are dealing with x and y now. Okay? So we got two situations. When we took this by this equal to this by this, or this by this equal to this by this. We have taken both the situations. We got one equation in the form of y, we got second equation in the form of x. Now, it is all about just simplifying it. Let's simplify one of them. Let's pick up x1. So it becomes, you multiply like butterfly. So m1 into x2 minus x will be equal to m2 into x minus x1. That becomes m into x2 minus, m1 into x2 minus m1 into x will be equal to m2 into x minus m2 into x1. Now take all the x's on one side. Okay, so it becomes m1 x2. I am taking x1 to the same side. I am making this guy to go this side as well, and bring this guy to this side. So m1 x2. This is minus here. It becomes plus. So m2 x1. This came here that side. Both became plus. Will be equal to m2 into x, and this comes this side, which is nothing but this part becomes plus, becomes m1 into x. So what you see here is x is common. If you take x common out, it becomes m2 plus m1. So if I want to find out x, I will get this guy to this side. Or let me not rush through this. So it became m1 x2 plus m2 x1 equal to x times m1 plus m2. So if I keep x only this side and make this guy go this side, this will become m1 x2 plus m2 x1 divided by m1 plus m2. So again, too much of complicated calculation. It is not. We got this value as m1 by m2 equal to x minus x1 by x2 minus x. We are just trying to solve this, okay? So we said, okay, fine, this goes this way, this goes this way, and you multiply it, and this is m1 into x2 minus x equal to m2 into x minus x1. That's how it became, okay? So you'll have to do this calculation, okay? You have to draw this. If you really want to master this, okay? If you really want to be comfortable, if you really want to deal with this in a more fun way, you'll have to get your hands dirty. See, after every class, this is what I keep complaining about. Look at my hands, how dirty they are. Yeah? You have to get your hands dirty. If you really want to learn math, I have been drawing on the board for last 3 hours now, because that's the only and the simplest way to learn maths. So here, from this one, what we found was the value of x became m1 x2 plus m2 x1 by m1 plus m2. Similarly, if you calculate for y also, the same thing you will get for y also. Y will be equal to m1 x2, m1 y2 plus m2 y1 by m1 plus m2. These two are called your section formula. Now you should go back to this one. This x and y, how did you find the value of x and y? It says that if you have to divide a line joining point A and B in the ratio m1 is to m2, the coordinate of C, which will be x and y, will be following this one. So first ratio times the second value plus second ratio times the first value divided by first and second ratio summation. That's what is section formula. Meaning, if you have 2 points and a coordinate plane and you know their coordinates, and join these 2 lines, and you have to find a third point on this line which divides this line to m1 into m2 ratio. This is the formula, or the section formula, that you will apply to find it out. Okay, and this is how the section formula is derived. Again, we did not do anything fancy. We had this, we just plotted it here. We found that these two are similar triangles, and similar triangles have sides in the same ratio. We applied that here, and then we were able to do it. I know it might sound a little overwhelming or tiring, but the easiest trick for getting past this is by scratching your pen on the notebook rather than scratching your fingers on your head. You lose hair, don't do that. So try doing it. If you get stuck, you'll have the video of the class. Use that to go step by step, and let me know if you get stuck anywhere. But summary of this is, when it comes to coordinate geometry, there are 2 things that we need to be aware of. One is called the distance formula, and second is the section formula. This is where you say x and y coordinate of the point which divides a line to this ratio is m1 x2 plus m2 x1 by m1 plus m2, or y coordinate is m1 y2 plus m2 y1 by m1 plus m2. This is what we derived. You don't have to memorize it. You can try doing it once, and then we can apply this formula to solve this problem. But if you have understood this, or if I was successful in explaining this to you guys, trust me, this is something that not everybody would know. I'm talking about kids till 10th grade. I'm not kidding. Now, I'll go around the table to see who is how stressed looking at this. Dikshita, stressed out?
No, sir.
You're able to relate, right? I mean, see again, whatever I teach, right? Trust me, I have no magic wand. Okay? I'm one of the most hardworking person you would come across, and that's the only thing I can pass on to you guys. That you have to do hard work. What I can do is, I can explain you the concept, and then you have to kind of dig through it, practice it, and make it yours. So far, this is mine. That's why I'm going to explain it. Once you practice it, this becomes yours. So the transfer of my understanding to you will come with your practice. Okay, I'm just giving you guys a path. Use that, try it, and once you are able to do it by yourself, trust me, you will be much more happier than me. Ritika, Vivan, Arihan, Pranav, Myra, anybody who could not even follow 30% of what I was doing. Tanu?
No, sir.
No? Everybody with me?
Yeah.
Ritika did not say anything. She is keeping her vote for later feedback. You got it? Okay.
Yeah.
Alright. Yeah, Nihan, what is your point?
And are we going to learn about like the slope?
We will learn that as well, but not today. Right now, we were just talking about the coordinate geometry part, and we ended up learning something little tricky or little complicated to begin with. I mean, trust me, you just catch hold of, just do this for fun, okay? Catch hold of a 10th grader or 11th grader and say, okay, tell me what is section formula in coordinate geometry and see how many of the answers you get and what kind of answers you get. Okay, and let me know what feedback it is. But yeah, in the subsequent classes we'll talk about the linear equations. We'll talk about the different forms of a linear equation. We'll talk about what is slope intercept form, what is the run and rise, what do you mean by the growth of a line versus a perpendicular line, and we'll talk to all those things. I mean, we had just gotten started with something on coordinate geometry. Yeah. All right. With so much of stress, with so much of worries, the only hope is we practice and snatch this concept from the teacher and make it yours. Okay? Alright. I'll let you guys go. Have fun. Talk to you guys tomorrow. I might plan to skip the class tomorrow. Okay? I have got some guests at home. If we end up skipping the class tomorrow, we'll have to find out some alternate, but probably we'll continue with the class tomorrow. We'll see. We'll see. Okay? In case I end up cancelling tomorrow, I'll try finding out an alternate. Okay? Alright?
Okay.
Have fun, guys. See you guys tomorrow if the plan doesn't change. Alright, bye bye.
Thanks.
Bye bye.